everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be learning about redshift and the Doppler effect for GCSE Physics students. I hope you guys find this video helpful, and if you're new around here, welcome to the channel. I'm a real life science teacher. I make videos in my spare time to help students like yourself or just science enthusiasts like yourselves learn more about science and achieve better knowledge, better understanding and enjoyment in the subject. So if you'd like to join us and be part of this community, you're very welcome to. Just click subscribe, it's absolutely free. And, thank you very much for all your support. It's just lovely to have you here. So let's talk about the Doppler effect. And the way to kind of get us into this is to think about a real life example. So I want you to think about the last time you heard a siren going off, whether it was a car siren, whether it was somebody playing loud music and was on a bike listening to that loud music and they were moving around you. Essentially, you will notice that as they're moving or as that sound is moving and traveling and you are staying in your own position, you're stood still, the sound actually changes. And yes, of course, it gets a bit louder as it gets nearer to you, but the actual pitch of it changes as well. Specifically, I think about like an ambulance siren. When that's a continuous sound going off, usually if you're driving or you're stood waiting for it to go past, you can actually hear the sound of it change as it approaches you and then as it goes away from you as well. And this is what we call the Doppler effect. Essentially, it's this idea of the change in sound frequency with movement of that object. And as it changes in motion, the frequency changes as well when you are staying still, as you are stationary. So it's all about the movement of sound and how it relates to you as the person hearing it. So let's give a bit more of an example on what we mean by this. So I want you to think about you are stood still completely and the siren with an ambulance, for example, is sounding, but the ambulance is not moving. It's just, for whatever reason, the sound is on and the sound is just continuous and you are stood next to it and the ambulance is not moving anywhere. Essentially, what you would hear in the first instance is that the siren is at a constant pitch. So the sound waves essentially are traveling at a constant speed throughout the medium, which is air. And therefore you perceive that sound with the same frequency, and therefore the siren sounds exactly the same all the time. In the second situation, I want you to now imagine that the ambulance is approaching you. So it's driving closer towards you. And this will actually change what you hear slightly. So because that siren is moving towards you, the sound waves are actually compressing. There is like a compression there. So they're actually getting squashed together in a sense because those waves are actually moving closer towards you, that they have less to travel as they approach. And it causes that compression. It causes that the wavelengths to actually appear shorter, and therefore the frequency is higher. There are more waves per second, and therefore this causes the pitch to sound much higher and more shrill, more shrieky. This is essentially, like I said, this is the Doppler effect happening because one object, which is yourself, is not moving, but the other object making the sound is, and that's what makes the sound appear different. I would also state at this stage, I would really recommend watching a video about waves. I have one on my channel, I'll link for you in the cards or the description box somewhere, so you can remind yourself, what do I mean by pitch and frequency and wavelength and all of that kind of thing, because this very much links to it as well. And then the third example, I want you to think, now that siren or that ambulance has been sounding, it actually starts to move away from you. So as the ambulance moves away, or the object that makes a lot of sound moves away, it actually causes a greater distance between you and that object. And therefore the sound waves are actually stretched slightly and causing longer wavelengths to occur, and therefore there is less frequency, so there is a lower pitch as well. So it actually appears much deeper in tone, is what I mean. So that is why we can hear, although it's the same sound technically, it appears slightly different and the frequency changes based on that motion. And this is, like I said, called the Doppler effect. So how does this link to redshift? Because when we think about redshift, we're talking about the color that we perceive. So if we think about that, we're specifically referring to light. So light can act as a particle, but it also can act as a wave, which is why we use the idea of the Doppler effect to relate it to redshift and this idea of changing wavelengths and changing speed and distance and things like this. Because before we were talking about the Doppler effect in terms of sound waves and those longitudinal waves. Light waves, we can actually think about the electromagnetic spectrum. So we see light in the visible light spectrum. Again, I've done a whole video on this, so feel free to go back and watch that. I'll link it for you. But Redshift is talking about light. And like I said, we know that light can actually act as a wave as well. So Redshift essentially is a way for scientists to see if an object, a celestial body, whether it's a galaxy or a satellite or a star in the universe, whether it's moving away from us or whether it's moving towards us. Redshift specifically tells us an object is moving away from us. And this is because if we look at the electromagnetic spectrum, like you can see on the screen here, the red section of light in the spectrum actually has longer wavelengths. And if we go back to that idea of the Doppler effect, if something's moving away from you, those wavelengths actually get larger, they get longer. So that's why it appears red, essentially. It's shifting towards that red wavelength, that wavelength which is a bit longer. Now, of course, with anything, we can have the opposite occur. So we have something called blue shift, which, as you can suggest here, you can see that if an object's moving towards you, we might actually see it as blue. And that is because those wavelengths are getting more compressed because it's moving towards you, which is really incredible because this actually gives us lots of information. It can tell us that our universe is actually expanding and other theories, which I'm going to run through with you now. So you've probably heard of the Big Bang Theory. Lots of people talk about this in everyday life here and there, like the Big Bang Theory. There's shows about it, all sorts of things. But what actually is it? So the Big Bang Theory essentially suggests that the universe began from a very small region, and it was extremely hot, extremely dense. And based on different bits of information, we can see that because of the Big Bang, we know that the celestial bodies that are in the universe are actually constantly expanding, and we can see that from this idea of redshift. We can see that because of that expansion of the universe, galaxies are actually receding and moving away from us. So we can perceive it in that sense, that it is actually increasing in size, and the universe is infinite, it's constantly expanding, which is incredible. We can also use Redshift to tell us other things about the universe in terms of other models of the universe. It can help us explain different observations, especially in the sky. So if we have satellites and we want to know if they're moving towards us or away from us, we can use Redshift and Blueshift to identify that. We can also do that with other potential problems if there's asteroids and things like this. In fact, you might have heard in the news recently about an asteroid that is in close proximity to Earth. So I'll link that for you in the description box. Some interesting information that's come out about that recently at the time of recording this. I'll leave some information, some just further reading for enjoyment purposes in the description box as well, like I said. If you have any questions or if you would like to share any fun facts or anything that you have discovered in your own learning journey, do feel free to comment down below as well. And I hope this has helped you guys. That's it from me today. I've been the GCSE science teacher and you have been curious. Thank you so much for your support. If you would like more content from me, I have linked a few videos for you. Like I said, I'll put some information in the description box for further reading for enjoyment purposes. So feel free to have a read of those. And if you would like to request any videos specifically, of course, you know you can comment in the comment section down below as well. Thank you so much. Have a great day and I'll catch you in the next one. Take care.